Hello and welcome back to a new video in Inventor. It's been over a year since I've done a video on YouTube, and I apologize for that, but it's been one hell of a year. The numbers just came in, and at the end of October we had actually registered 183% contracts against last year, meaning we've managed to cram 2 years worth of projects and work into a single one. And then I had the Autodesk forum where I try and answer a question or two a day to help that out. I'm answering all your questions on the blog, on the Inventor forum I've mentioned, on YouTube, and any personal messages that I receive. I also try and keep a blog a week. That's very difficult. I mean, I've got 50 drafts, 130 posts still in draft on Tube and Pipe Idea Station in Inventor. So it's been one hell of a year. Been doing 16-18 hours a day, and on top of that, some of you are aware, at the end of March I've lost my father. My father has passed away. I'm still not, and I don't think I will ever recover from that. Anyway, what made me come back and do a video was one of you have contacted me. Let's not give names, company names or personal names, but he was trying to, his company, which is quite big, is trying to do self-draining lines, and he's into pharmaceutical, dairy, and this sort of products, and he's doing skids and plant layouts. And lately I've been doing a lot of self-draining lines and a lot of pharmaceutical products, skids and plant layouts. Quite nice products. And he asked for my help to see if his workflow is possible, because at the moment what they're doing, they're constraining every fitting and every pipe and every single segment. And he was trying to see if it's doable with Tube and Pipe. Now his company has actually opened a support case with Autodesk, and after a thorough investigation, Autodesk did a report and came back, said this is not possible, forget about it, just continue doing it the way you're doing it. And in the back of my mind, I always knew this is possible, and I'm here to prove it. So yeah, after 1 year, what better start than to do another video on Tube and Pipe. I know a lot of you ask me, how come I cover only Tube and Pipe? Do I only know Tube and Pipe? No, I pretty much know every single module of Inventor. I've been using it for more than 12, 13 years now, so I know it inside out, except for mold design and maybe dynamic simulation. But it just so happens that the Tube and Pipe module is so outdated, so much missing information on it. I just find it easier to post about Tube and Pipe, especially because I use it daily on my skids, on my plants layout. So in trying to solve his problem, I actually got the most important phase in any design is getting the user requirements correct, and I failed to do that. I didn't understand. We were kind of lost in translation. We're obviously from different countries, and I didn't quite understand what he said. What they're doing, and what I first understood, is that they're using 90 degrees elbows. Not sure if you know, on self-draining lines, you don't have quite 90, it's either 92 or, depending on how much draining is in their specifications. If you go ask me BP, there's 0.57 degrees, or 1 in 100 or 1 in 200. Anyway, that's not going into details. So what I thought what he said he was doing, what I understood first time on the first discussion that I had with him, is that he's using 90-degree elbows, and then they cut them to the required angle, and then they weld them. Sometimes they cut because they work in very confined spaces, and I'm guessing skid design mostly. So he said they're cutting back the elbows, and I assumed that they're cutting it at an angle, just to match the slope. There's two ways you can go about this. You can leave one side straight and just cut the full angle on one side, but I've actually cut it equally on both legs. The reason why I'm still showing you this, although it's incorrect, it's not what he was after, is because I found a couple of interesting things. First, I started to think about how am I going to cut it, just so the minimum cutting distance would give it a full face, and the maximum cutting distance would still give it a full face. If you see what I'm trying to get at. So I have, and also the other interesting thing about this, which I would like to present, I'm sure for those reading my blog and viewing my video, you guys are familiar with how to alter empty parts. And why is that useful? It is useful because in the case of this elbow, even though the elbow is 90 degree, the connections were actually 88 or 92. So the challenge here was to, although have a 90 degree elbow, to have different angles on the connections. And that's one thing that I want to show you. What I've done is, first of all, I've created a couple of lines which will be my cutback distances. Right now it's on 0, so let's just change these for a second. Let's just change cutback to the 5 inch. Oh, 5 inch is too much. Let's just go 15 millimeters and 5 millimeters, just so we can look at some distances and see what's going on. Yeah, so that's going to be my cutback distance, and that's, I just actually flipped on the other side. Let's just look at this one. That's my cutting angle by 2, because I want to half here and half on the other leg. That's my cutting distance. And I've created these construction lines here, which will serve as my connection axis. And right here, where the split line is, because I'm using a split to trim the sweep, and I have another point there, those are my connection points. Yeah, so if you ever need to do something similar, keep in mind all you have to do is create directional lines which will serve as your axis and some points to where the connection will be. I don't recommend that you use the face for authoring, because when you use the face, keep in mind that the split, you could actually end up splitting it right there past the bending line, and this circular face, this will not be circular anymore. So I recommend that you go through the process of creating a point and a line, and then in the author window dialog you actually select the axis as being your axis. You see that? Let me just align it. So I recommend that you use those, yeah, and the point as your connection point. And because they're all part of the, sorry, the other one, they're all part of the same sketch, if whatever I change to the cutback distance, then the connections will change as well. I've also developed a formula about giving me what the minimum cut distance is to create a full face, a full angle. Yeah, although you can go to, say, 0. Let's just finish this and I'll show you. See, this doesn't create a full face, it kind of creates a half straight, half angled. Anyway, these are just details, but I will provide this file as well on the blog if you want to open it and play with it. Yeah. So let's just see how this goes. Let's publish this to Content and publish. We're just going to publish it as it is. I'm not going to bother about entering a lot of details. So I'm having C2 and where is it? And D is already there. Yeah, that's it, and that's the order that I want to be prompted. I can also change this later, but so let's just call this sorry, cutback 88. I just want to put something so I can find that. Publish. Thank you. Now let's start an assembly and tube and pipe and see how that works. Let's save this. I'm gonna call this O2. Just give it a name really, and then we're gonna start tube and pipe. I like to simplify this. I don't like the default names. Tube and pipe, and then the default location. Oh, it's just terrible. Get that off. Call it TP. You can easily go into and get over the 254 characters that Windows allows. You know, depending on where you are. We're gonna call it, yeah, that's O2. That looks good. That's fine. Now, before you can configure a root as a self-draining, you need to come back to the main tube and pipe and then define gravity. Gravity, for some reason, it's always in the wrong direction, so I always have to flip it. It's never Z going up. It's not going to the sky, the gravity. But anyway, okay, and then we can go back and let's look at the styles, and we're gonna try and import a style. And I don't have my library with me, so we're just gonna have to use the existing one. Let's just make it active. Well, just call it cut back. Oh, what's going on? Edit, please. Just call it cut back 88. Yes, it is a self-draining butt weld flange, but instead of the custom elbow here, we're gonna choose ours. Yeah. Okay, 1 inch, that's perfect, that's what I want. We close that and start the root. Ooh, did I activate that? I bet I didn't. Oh yeah, it is active, okay. So, start my root. Now, because we've specified the self-draining, you can see that it already gives me the angles, yeah? It's just gonna go down, oops, sorry, 350, say, I'll keep 350, and then we're gonna try and go, I don't know, 300, no, let's just leave it like this for now. I'm still missing a constraint. Make this fully constrained, just the way we like it. And now let's populate the root and see how that looks. Oh, I know what I haven't done. Let's look at the styles. I need to tell you this. In the styles, we're going to look at the correct example anyway later. In the rules, make sure you have 0.1 millimeters as the minimum, or whatever, a smaller. Do not display a gap. And just put the 0 as a gap. I don't want a gap. And let's see how that looks. See, that leg looks correct. That's correct because it's straight. This, it matches the face because that's how our connection was. And this matches the face. But this doesn't quite look right. If you see it, it's going, you know, inclined there and the wrong angle here. And I'm not sure it's quite, maybe it is fully drainable, but I'm not sure, I'm not convinced. Anyway, what he really wanted was, he said, no, you got it all wrong. I am cutting back the leg, the length, the standard elbow, but we don't cut it at an angle. What we do is what everybody does really, because to buy 88, 92 degree elbow is very expensive. So what we do is we tend to take a 90 degree one and we just bend it for 2 degrees in or out depending on where you need it. So he said that's exactly what we're doing, but we're also cutting back this to give us as minimum possible distance. So sometimes we only get this radius, or we were just cut off one leg, or we just cut both. It all depends. Okay, so that's even simpler. Yeah, that's gonna make things a lot simpler. So let's try, and I'm gonna get rid of these splits. We're still gonna keep this. But one thing that I recommend is, and we're gonna prove this later, is before you publish it to Content Center, you actually make the legs 0 length. Because when you will create a route, you know, there's a minimum distance that you're allowed to have, you know, on consecutive bends, like in here, for example. See, that will just violate the previous segment. But if you publish it with the full leg, then your minimum distance will be bend radius plus full leg. But if you publish it with just the radius, then your minimum distance will be only the radius. Okay, I'll show you what I mean. Right, so I finally modified this, and when we change it, we should be able to publish it to Content Center now. I have minimum maximum distance to allow just the radius. So let's go ahead and publish it. Hopefully it will work. C1, oh, sorry, C2, that's the first, second. Thank you. But we still need to edit the family table. I'll show you why. Where are you? So, even though the value is going to be in inches, we want the user to enter millimeter units. And we're going to say that's custom greater than 0, 1 millimeter increment, where in fact that's not needed. Give me 2 and 3, and then we're going to paste in here maximum is actually going to be max distance, and the default value is going to be max distance. And I'm going to copy this into my second one, and we still have one problem. The file name is not unique anymore. Let's just make an expression. Oh, sorry. Let's just say member. And C1. Copy this. Put it again. C2. Now it's a unique file name. It's going to generate unique file names anyway. Thank you. Let's come back and see how this works. Edit the style. Deleted. I have removed all the old families. I'll just add hours now. That one. Saving curls. What we said? 350. Oh, sorry. Come on. 350. 300 now, because we've published it on just the minimum. I should be allowed to specify like a really small distance. Let's make that even smaller. Let's say 40, because it's less than more than 38.1, which is 1.5 inches. So that's possible, and I can even have this as 40. See, that's what I'm talking about. Which one? Yeah, it's gonna be 2 radius, so it's gonna be 76.2, which is 3 inch, 2 of 1.5 inches radius, and voila, and there you have it. in fact it's less than that. So very good example. See, on this end, I just changed it to component. On this connection it gave me a 0 connection, but in here, because it was slightly bigger, yeah, it created a pipe segment. Now I have two options. I can either change size on this, and here's another very interesting fact. The way you create your route is going to be the way it's going to be populated. What I mean by that, this first segment, there's connection 1, that's connection 2. On this elbow, that's connection 1, that's connection 2, and so on and so on. So in fact, I know that if I change size, and if I specify connection 1 cut back to 0, and second, just say 1.5 inches, 38 millimeters. Is that too much? Can't really tell. Just say 10. Oh, I can't. I can't because of this. I need to go at least. I have to modify this. Just make this 100. This 50. And now I should be able to change size. Say connection 1. I'll say don't cut it, and connection 2, cut it at 38 millimeters. I wonder why it's still giving me, I didn't set inches for the second. Oh, see, let me stay that it's still in inches. That's why. No. That's how it needs to be. Now I need to refresh. So I save everything. Let's try refreshing here. It's all the same. Oh, sorry. One too many. Now let's try. Change size. So I've got millimeters and millimeters, even though the value shown is in inches. I'm going to say 0 on the first connection and just say 38 on the second one. And I'll just see what happens. This should be full leg, and this one should be 38 millimeters cut back. See? How's that? So it is working. Those that follow my blog or the YouTube channel know that you have basically two options for doing consecutive fittings. You either change the style to a very small segment and allow Inventor to create a small segment in here. In fact, let's just do that and prove it. Let's change size, and we're going to cut the second one to 39.4. That's a limitation of Inventor. I think it doesn't allow you to go quite the maximum. I should probably change that in the table. It allows 39.1. Nope. Don't know why. For some reason. We'll just make that as small as possible. And the second one is already as small as possible. In fact, I could do it this way. Drop it on top of that one. So I know that I can take it back. Is that correct? I can take it back about 26 millimeters. Just say minus 26. And that's one way to create consecutive fittings and just ignore that small segment that Inventor creates. No one will notice. Or the other way to create consecutive segments, let's just drop one in there, is to just leave it straight and then place another one. Connect, sorry. And in fact, even if you've done it this way, I haven't tried this, but let's just try it real quick. I bet you can insert a bit of pipe in here. So let's just copy this one and do a save replace, and I'm going to save this. Yeah, that's correct. And then I'm gonna I was gonna try and place okay, no worries. Edit fake connection. Let's just remove that. I'll connect it manually. You cannot tell me what to do. And then you can always change size and change length on this. You just say 10 millimeters. And a lot of you will say, well, you know, what's the advantage instead of doing constraints? Why wouldn't I do a constraint, and why would I want to place it like this in here? And I hear you, and I understand what you're saying, but think about it. In Tube & Pipe, you actually don't have any constraints. So Inventor is not processing any constraints, is not computing. These are just connected, and they're grounded. And grounded members are perfect. They don't. It takes nothing to compute. And that's about it, really. There's a longer video which I'll have to do at some point about doing self-draining lines, because if you look in the it's not possible to do fully self-draining lines. I mean, in Inventor, if you look at the style, you can only specify one elbow, and that's either a sharp angle or an open angle. It's either less than 90 or bigger than 90. You cannot specify two. A lot of the times in pharmaceutical, and you know, whenever you have long pipe runs, you don't just have a slope in one direction. You have a high point in the middle. Just imagine you have a pump at one end and you're pumping, and then by the time you get to the vessel, to the stainless vessels, or wherever your points of use are going to be, you cannot just keep rising. So you're going to have to create a high point in the middle and then go down in the other direction. So it'll drain in both directions, if you know what I mean. But Inventor doesn't permit this, and for that you need to work with tubing with bends. But that's another viable solution. I've been using that a lot, and you can even use it to create bill of materials. I know it sounds weird. How can tubing with bends be used to create bill of materials? You can extract elbows and exact segment lengths from that as well, but that's on another video. Thanks for watching, and sorry for dragging and for making this video so long. I'll see you all next time.